Hello and welcome to IonGap. I'm your host, and here on this channel we make complex medical and laboratory topics simple, clear, and understandable for everyone. Whether you are a student, a healthcare worker, or just curious about how our body works, you are in the right place. Today we are diving into a fascinating topic: how our kidneys, water, electrolytes, and acid-base systems keep us alive and balanced. Don't worry, we'll turn the science into a story you can follow. Imagine your body as a giant water tank, divided into two neighborhoods, inside the cells and outside the cells. Water flows back and forth through tiny gates called aquaporins. These channels always making sure both neighborhoods have the same saltiness or osmolality. But here's the twist: not all molecules play fair. Some, like sodium or mannitol, stay stuck outside cells and pull water out. These are called effective osmoles. Others, like urea or alcohol, slip through freely, so they don't really move water around. Those are called ineffective osmoles. We can actually measure how salty the blood is. This is called plasma osmolality. Doctors often estimate it with a quick formula about 2 times the sodium level, but sometimes the number don't match. If the measured value is much higher than the calculated one, we call that an osmolar gap. Why does that matter? Because it's often a hidden clue. Things like toxic alcohols like methanol or ethylene glycol creep into the bloodstream, raise the true osmolality, and create that mysterious gap. That's how the lab can save someone's life before it's too late. Now let's meet the kidneys, the ultimate guardians of balance. Their main job is to filter the blood, keep what we need, and toss out the rest. But measuring kidney power isn't simple. The gold standard tests are too clunky, so in real life we rely on estimates like the EGFR, which uses creatinine in your blood. But creatinine has its limits. For instance, if you have got a lot of muscles or lost them during an illness, the results can trick us. And then there is potassium, the spark that keeps every heartbeat alive. You can think of it as the electricity that keeps your cells firing. Most of it lives inside cells, with only a tiny bit in the blood. If potassium moves too much in or out, your heart rhythm can collapse. Hormones like insulin and adrenaline can push potassium back into cells, like a reset button. But conditions like kidney failure or hormone problems can let potassium build up outside, leading to a dangerous condition called hyperkalemia. Now, what is the relationship between water, salt, and thirst? Our body is wired to notice the tiniest changes in water balance. A 2% rise in blood concentration makes the brain release ADH, a hormone that tells the kidneys to save every drop of water. On the other hand, a 2% fall does the opposite, making urine as clear as water. But sometimes the system misfires. In a condition called SIADH, the body makes too much ADH, which results to drowning the blood in water and diluting sodium. Also, in conditions like heart failure or liver diseases, salt and water pile up in all the wrong places. And lastly, there is a condition called hypernatremia, which happens when water is lost faster than salt. which makes the cells dried and shrunken. Finally, let's talk about acid-base balance, the chemistry of life. The blood needs to stay near a pH of 7.4, and it does this by juggling two partners, bicarbonate and carbon dioxide. If one rises, the other adjusts. But when the kidneys fail to keep bicarbonate or when the lungs can't clear CO2, the pH shifts. The body tries to compensate, but it can only bend so far. By looking at blood gases, doctors can tell if it's a simple imbalance or a complex mixed disorder hiding underneath. So that's the story. Water and salt deciding where fluid goes, kidneys acting as guardians, potassium sparking every heartbeat, and acid-base balance fine-tuning life's chemistry. This was chapter 15 of Henry's Clinical Diagnosis, retold for you here on IonGap in simple terms. If you found this helpful, hit like, subscribe, and share it with your friends. I'm your host, and thanks for joining me on this journey through the hidden science of your body.